Hi, I'm Oliver Gao. I'm the Director of Cornell Systems Engineering Program. I have been very fortunate to conduct what I call these systems conversations with our very prestigious speakers that Cornell invites to our Cornell Systems Ezra Seminar Series. Today I'm very delighted and honored to have Dr. Edward Tunstel. And Ed is actually an Associate Director of Robotics at United Technologies Research Center, leading a robotics group focused on human collaborative robotics. So actually Ed was a senior roboticist at Johns Hopkins APL, researching robotic intelligence, autonomy, modular open systems, and he was previously with NASA JPL as a senior robotic engineer. So Ed, he has many titles. I just list a few. He is an IEEE Fellow, IEEE SMC Society Past President. So which means that he's not only himself doing great work, he has also been serving, the society, this professional society, and also he is, IEEE Robotics and Automation Society member, holding a PhD in electrical engineering from University of New Mexico. And before that, he got a degree from mechanical engineering from Howard University. Mm-hmm. So Ed, it's really a pleasure to have you. Welcome to this system conversation. So as we briefly talked about, I was really amazed about you were initially interested in art, and now you're working on robotics. Those two things, of course, seemingly not directly related, but I bet you have probably discovered something that connects those two beautifully. So I think looking at your career, I think not only me, I guess our audience would love to hear more about yourself, your career development, and how you evolved into this date, looking at all these whole complex systems. Robotics, and also interactions between humans and robotics.
Indeed.
So now I get it to you.
Absolutely. Well, thank you. First of all, I'm glad to be here. Glad to have this opportunity to share about my background as well as interest in the field of systems engineering and robotics and so on. Hopefully this will inspire and influence some of the thinking of the people who get a chance to watch it. You asked about my connection to art. So this goes way back to when I was very young. And I used to do a lot of drawing of different things. And I really got into drawing things that I could see. I could open up magazines to take a look at an interesting picture and try to draw that. Anything for the most part. Some things that I came out of my own imagination as well. But whatever it was, I was very active with just drawing. And as I started to get further along and think about what I really wanted to do, career-wise, the first thing that came to mind was architecture. Because that was sort of a thing that, you needed to sort of have some sort of drawing or artistic skills, certainly a creative imagination, and that sort of thing. But, and it also required some level of analytical thinking, right?
Yeah, abstraction, yes.
Exactly. And so I started initially to gravitate towards that. This was in high school. But I ended up going to a seminar at the New York Academy of Sciences. I grew up in New York City. And I was a junior in high school. This was a seminar and a panel of engineers and architects. And I listened to what they had to say about what they do on their daily routine and that sort of thing. And I remember walking away from that thinking I was actually more impressed with what the engineers had to say about what they did. And that is really what got me starting to think about engineering. And from that point on, long story short, I ended up majoring in engineering as an undergraduate. And but the connection between art and engineering, for me at least, was I considered robotics and robots in particular as art that moves. These were the types of things that I might find myself drawing, years prior. And if you could imagine animating those drawings in the form of whether it's cartoons or what have you, this is what robots appeared to me as, art that moved. And so in a way, it was kind of not so much of a transition, but a strong connection in my own mind between at least the type of art that I was interested in And this notion of these devices that you could actually learn how to control.
That sounds beautiful. So it means that that's one way of actually expressing and I think unleashing your potential in arts. Just this is just one channel.
That's right.
Yes,
that's right. And so in doing so, I actually became more and more and more acclimated to just engineering in general, and I saw that as a really, really fertile field to go into and have the opportunity to create new things or to improve existing things, mostly through your own and your colleagues' thought processes. Mm-hmm. And this is really even today how I think of engineering. But robotics really allows me to manifest a lot of those inclinations on real projects. Mm-hmm. Whether they're from scratch, thinking about a new concept, or whether they're dealing with an existing system that you need to somehow improve or enhance, and bringing those types of ideas and ways of thinking to the table.
That's beautiful. And I really appreciate you said robotics to you are like arts that move.
Indeed.
Right. I think that's really very such a nice quote unquote definition.
Yeah.
Right. Because when you talk to a lot of general public, when you talk about robotics, people say, "Oh, that's high technology."
Yeah.
High technology.
Right.
But I think the way you approach it, it's really yes. At the first sight, it is a physical technology.
Yeah.
However, the creation of that technology, like for what purpose?
Exactly.
And serve what kind of goals? And really, that has so much to do with arts, and also that has too much to do with identifying, not only some philosophical questions, ethical questions.
Indeed.
Right.
Yes, you're right. Absolutely.
So please continue. Yeah, I just.
Yeah. So no, these are very good points. And so, and in particular, the sort of public perception aspect of it.
Yeah.
Because yes, indeed, we're at a point now where this technology is becoming more and more real, and we've got. I often talk about it from the point of view that we've been using or spending the good part of the last several decades working on trying to make different aspects of robotic systems real and able to work reliably. We're still on that path. We're not actually quite there, even though we have some existing robots in use today. But by and large, there are elements of technology that go into robotics that we've been working on consistently for the past several decades. And some of those things are now quite mature, but all of them are not. And so when you try to really integrate these things into a real robotic system, chances are you've got something that works most of the time, not all of the time, until we continue to penetrate and make advances in these other elements and make them more and more mature and ready for prime time. And so I always try to remind people that even though we're starting to see more and more evidences of robots being used in the real world, it's really still a research area.
Absolutely.
It really very much is still a research area. But again, enough things are working well enough that companies, organizations, space missions, and so on are starting to use what does work today. But really the public perception, even though there's in line with this kind of a fear developing, right?
That's
around, also related to things like machine learning and AI, right? There's a sort of interesting fear developing. I think most people who are working very closely in the field, developing these technologies, are the ones that you tend to find not so afraid. And I think one of the primary reasons is that we are very, very well in tune with the current state of affairs. And we know, or most of us feel, that before these things ever get to a point where they're very scary, it's going to be a long time of development, because really this stuff is really tough to do.
It is.
And to get things to work reliably enough that they'll end up in your home, it's a long path between whatever you might see on the internet today and those actual realizations.
Yeah. So, Ed, wonderful. I think it's kind of, you mentioned, while there is, excitement, but for the general public, there seems to be also kind of phenomena of fear.
That's right.
Right. So for this, of course, I think the general public, could be in fear mainly because they either don't see the big picture, or they don't see kind of the small picture. Mm-hmm. Right. So it's kind of fear. A lot of times comes from not knowing and not certain.
Yeah.
Right. What things are ahead. So at this point, I would probably, especially with your expertise area and also your career, maybe I would like to probably suggest us kind of approach this at two levels. Mm-hmm. First, kind of let's jump out of these kind of specific technologies and then to the 30,000 feet level. If you think about today's societal challenges and societal needs and our development needs. So from that level, and then we go down to where all this robotics technology fits, mm-hmm. right? So what do you see? Because you work on all these things. First of all, they've got to have some kind of market. Mm-hmm. Second of all, mm-hmm. even if we have a higher aspirant, they have got to address some societal big challenges or needs. Yeah. So what do you see in your related area? What do you see as major challenges or mm-hmm. societal needs?
Yeah.
Just in general.
Right.
Yeah.
Well, one of them that's developing more so today in certain parts of the world than in the United States per se, but for example, in Japan, the elderly population, mm-hmm. right, is increasing, and there's not a lot of human resources to tend to that population. Mm-hmm. And this has been one of the reasons that Japan in particular has invested over the last decades quite a bit in robotics technology to create, if you will, a technology that can tend to their elderly population. And it's no surprise then that you notice in Japan there's lots of investment as well in research.
Yeah.
Not only in the robotics aspect of things, but also the social aspect. There's no mistake that lots of the robotic systems in Japan that are being developed through research and through some companies actually take more or less a humanoid form. There's no mistake about that.
Yeah.
Because part of what they're trying to achieve is some degree of social interaction ability, something that will facilitate social acceptance as well by those that elderly population. And so this is one example, at least, of a real societal need, mm-hmm. today very specific in Japan and some similar countries with the same sort of issue, mm-hmm. But where part of the answer is to look at this kind of technology,
yes.
right? And so that's one. Another aspect is in today's factories all across the globe, a lot of what's happening in certain business sectors is that there's a growing demand for certain types of products and services. If you take aerospace, for instance, or aviation in particular, there's an expected increase in air travel mm-hmm. from now and going into future years. At the same time, that means that there will be a need for more aircraft and more aircraft components to be produced.
That's right.
At a faster rate than the companies that normally do those things are used to doing it, right? So the yes. demand for their products and services is increasing, which means that they need to produce these things at a quicker rate. Mm-hmm. But then what does that mean? Go down a few levels, the people and the factories and institutions that actually produce those things, they work at a certain pace, and they're being asked to increase that pace. Now, go back another level, go down another level.
Yes.
What goes into producing these things? At least in the aerospace industry, many hands go into
yes.
these. The aerospace industry, for example, is not as automated or does not leverage automation as much, for example, as the automotive sector. Mm-hmm. A lot of what is still done and manufactured and what we fly in all across the globe, many of us all the time, are built by hands.
I see.
So in order to increase the rate of production, one response might be bring in many more people to do this. Mm-hmm. But on the other hand, the skill sets that it takes to do some of the specialized manufacturing is in some cases so specialized that the people who are really good at it are well into their career, decades, and not very far from retirement. At the same time, they are not necessarily transferring their know-how to a younger generation. So effectively, not long from now, we will lose the capability of those craftsmen who did this work, right?
Yes.
So this is another area in which automation in the form of robotics and robotic systems is being looked at as a potential answer.
I see.
Can we develop robotic systems that can do some portion of those jobs and at the same time help increase the production rate, help improve the quality, help reduce the variability that you might expect to happen from one person to another person when they produce the same thing by hand, or from the one person on Tuesday to from that same person on Thursday.
Yeah.
There's even a variability. And so robotic systems that are inherently more consistent in what they do time after time may also reduce the variability, which enhances the quality, et cetera, et cetera. And so this is another current sort of social, I'll call it techno-social problem,
Yes.
right? That, again, part of the answer that's being looked at is in the area of robotic systems. So that's another. Medical area, healthcare. There's lots more surgeries that are going on these days, and we're finding that medical robots, robots that are actually teleoperated by medical doctors and surgeons, are finding more and more use. They allow you to do certain surgeries without being as invasive in cutting open a person and having to do that be a requirement in order to make any progress on a particular surgery. This is going to have better outcomes through healthcare types of processes and so on. It's already happening right now, but it will be more pervasive in the future. This also starts to enable the ability for a master surgeon in Ithaca, for example, to perform a surgery on someone across the world, in Europe, for example, via telecommunications, where the robot and the patient are in Europe, but the surgeon and his know-how and capability are here in Ithaca. Through the same technologies, what's being developed, was starting to be used more and more in operations rooms and facilities. That particular surgeon can then now operate on patients remotely. And so again, this is something that's going to enhance and improve things in the future, but it's really developing now, becoming more and more popular, more and more reliable, more and more accessible.
Wonderful.
Yeah.
Thank you, Ed. I think it's kind of you really helped me kind of. I think you gave, if I may summarize, kind of three categories of examples or needs. Like for example, like the Japanese example. For example, like aging of population that needs to be serviced. While we don't have enough population, and then robotics can play a very significant role in helping that aspect. And also, I think you talk about industry and the manufacturing sector. Especially even in aerospace, you say that kind of, how can we replace, all these hands? Or
at least augment them, because we still need the people.
Yes, that's right. It's kind of repetitive.
Indeed.
Yeah, Indeed. Those work. And also, I think the medical surgery, that's definitely, I think, you may kind of reduce the variability, like from a Six Sigma
that's right. Indeed.
Point of view, because, when the machines, when the robotics are programmed to do things, they are more robust, stable, right? Less variability. I think those are very good, aspects that really gives us the sense about the needs of developing this robotics. But then, what makes people fear?
Yeah.
So what are some things kind of other people, other aspects?
I think the quickest way to answer that is science fiction. And what I mean by that is science fiction in the form of books and movies has really seeded an imagination that is maybe the initial or the biggest or strongest catalyst to fear. when we think about robots and robotic systems. And what I get that from is basically, these are the venues through which our minds are taking on journeys to think about things like robots taking over. Whether it's taking over the world or in like a movie like iRobot, the modern one where you have them in your homes, they're in all parts of society, they're on the street, they're in the department stores, and they're helping. But at some point, by some means, somehow they become malevolent.
They rebel.
That's right. And there's always a rebellion that occurs, and usually a miraculous human recovery of power, right? And so this is a common thing that develops in writing and in film. And it's entertaining, for sure.
It is.
But why wouldn't we think, as a society, when these things start to become more real in our real life, that wouldn't be the trajectory, right? Because we're so influenced by the what we've been entertained by.
Yeah.
And not to trivialize it entirely, I mean, there is something there. I mean, we're talking about in a time when more and more researchers, more and more practitioners are applying machine learning, applying artificial intelligence. These are words that have many definitions. And depending on who you talk to, oh, it doesn't sound so scary. Oh, wow, that could be really, potentially dangerous, right? And so this is at the same time we're talking about those technologies, and so people can easily imagine, oh, you've got an intelligent robot or a smart robot. What does that mean? Does that mean that that robot will be able to learn from others, not only other machines and robots, but from people? And what will it be able to learn? Will it be able to learn from people who are bad actors? And what does that mean? Will they be able to become more and more autonomous because they have the ability to learn on their own? These are all great questions, right? And I think they all lend to a particular fear of the unknown. How far can this go? And there's a current, very vibrant conversation around this within the technology and the research and development communities. There are groups that are forming around the concept of ethical design, for example. How can we harness these technologies while at the same time producing new and great things in an ethical way that in some way addresses some sort of containment of a potentially fearful product.
Yes.
Right?
Yes.
And so this is good. This is good that we are having that dialogue, those conversations at this time, because again, as someone close to the technology, I actually think it's a long time into the future before these things really become capable of doing anything we might be fearful of. But if that's true, it's great that we're having the conversations around ethics and responsible design now. Because that potentially means that someone who is 6 years old now and comes up in an educational system that has a sensitivity to responsible design and ethics by design and things like that will be the future engineer who is deploying robots that actually have enough capability well into the future. And chances are, if that's the case, those robots will be unleashed, if you will, on the world in a much less threatening condition.
Thank you so much. I think that's a very I think comprehensive, and also I feel you are in this area. However, I think you provided a very unbiased. If I'm doing something on some subject, I think this is really good. I cannot see the downside. Seldom, right? But I think you were able to provide both, the upside and the downside. And it seems to me I think in your we were talking, it seemed to me mentioned two dimensions. One dimension is the technology itself, like robotics itself. Robotics itself, there could be, let's say, I'm just simple, good robotics and bad robotics. Not their technology, but what they're doing.
Sure.
Right. So another dimension is even the same technology. Say it's a good technology, but who is using it.
Right.
For what purpose? Like one point is the technology dimension, and another is social kind of who is using that. I think there is reasonable excitement as well as concern. Just for example, atomic bombs. Right, it's a powerful technology. Right, it's the technology itself. Right, it's really powerful. From technology point, it's really a good technology.
Indeed.
Right, and then in what people's hands.
Right.
And what they're used for. So that, of course, that is probably beyond, engineers.
Indeed.
To answer that. So, but always you can see that, of course, we do a lot of optimization. In optimization, it's really, I think, striking a balance. Right. So just imagine, this question. I'm just thinking to myself when we were talking, but I don't know if we can, try to answer it. So imagine that there is this one extreme point. There is a spectrum of all this technology. Let's just look at the technology, right? We say good robot and bad robot, and then we as an engineer we're working on these things. So to what extent, like where is the red line? Like we as an engineer we say, okay, yes, we're working hard to build all these technically capable robotics, and we're pushing the boundaries. Because you mentioned also like responsible and ethical design. So you said, yes, we'll try to make all these robotics as powerful, as capable as possible. But at a certain point, we tell ourselves, we need to stop. We should not build robotics beyond that point, such as that. I don't know where there is that red line or not, and how do we decide on that red line?
This is a good question, and I can't claim to have the answer. But
I know it's a challenging one, yes.
Oh, absolutely. But I think it's a good one to think about. But I think that I'm not so sure that there is a red line, and I'm not so sure that the spectrum, good robot, bad robot, is a necessarily valid spectrum. And what I mean by that is that whatever forces there are that would want to use the technology in what we might think of as a bad way, they could probably succeed at taking a robot on the good robot end of the spectrum and making it a bad one. And likewise, one on the bad end of the spectrum with the right know-how and so forth, one could probably make it a good one. So I think that as long as there are these forces out there, people who want to do different things with the technology, this is something we always have to deal with, even with existing technologies today, right? You take the internet, for example, wonderful in many different ways, but many have found really not so good ways to use it, right? And so the thing is, we are, as a society, we're advancing technologically all the time, and we will continue, but there'll always be, some element of our society that uses the advances in a way that we don't generally agree with. I'm not so sure that there's anything we can do about that, except one of the best things we can do is what we were alluding to earlier, things like, for the folks who, as part of their day job, are involved in creating and advancing these technologies. If we can at least have them do what they do in a responsible way, that may be the best that we can do. Because no matter what you end up with, no matter how hard you try to create the most cyber secure robot that no one can penetrate and all it does is good things and good behavior, no matter how hard you try to get there, there will be a way for someone to think about how to turn it around.
That's right.
Or if they can't, if they give up at penetrating your cybersecurity defenses, then chances are they might understand enough about what you've developed to develop their own. Right. And so I think we'll always be dealing with that and trying to strike that balance. And maybe perhaps the best thing we can do is just instill within our engineering, science, education, ways and means and sensitivities to being responsible and ethical.
And I think I very much agree with you. I think you mentioned the keywords. These technologies, technology itself, it's at least neutral, right? And I really like what you're saying. Kind of, how can we establish a responsible way? And that's right. I think how can we establish a responsible social technical infrastructure in the design of all these technologies, such that those different social elements, ethics, are considered
Indeed.
in pushing those boundaries. Right. Of course, just when we were talking, I remember that my research is in transportation. Just a very simple, on the highway we have a speed limit.
Sure.
We can always build cars, right? They can run 60 miles per hour, 80 miles per hour, 100 miles per hour. But somehow we can see that we apply a speed limit.
Right.
Of course, that speed limit can also be changed
Indeed.
over time.
Yeah.
Right. You can see that. Say when we have this human driven vehicles, for example, we have 65 miles per hour. Just imagine when we have autonomous vehicles, right? There maybe that speed limit, could change.
That's right.
Right. So which means, however, the key thing is that we do have a responsible way of analyzing and identifying that speed limit.
Right.
Right. Yeah. That can change. I think
exactly.
So I think this it's really through this discussion that I think that can help illuminate, because a lot of people without knowing this analysis, people say, oh, it's really dangerous. But you cannot say, oh, because when I'm drinking water, I can get choked and I won't drink water.
Yes, right. Exactly.
Right. So with that, now diving into your specific kind of area, because you're working on, especially you're working on this kind of this next level of this intelligent kind of robotics, and especially how they interact with human beings, and also even how to design. So first of all, what are the technological frontiers and boundaries that you and your team have been trying to push against?
Yeah. Well, I would say, frankly, one of them is really the technology itself and its current limitations, right? And so you think about, I talked a little bit earlier about the sort of aerospace manufacturing area, and the fact that one of the partial answers to its current dilemma is to look to automation, and in particular automation in the form of robots. Well, robots today and their current capability is not at a level where you can just turn them on and put them in a factory setting next to people and have them work as a productive partner, if you will, almost like an apprentice or something like that. Today's technology is not quite ready. And so one of the frontiers still is trying to develop and advance the technology to the point where you can do that. But what we don't want to do is try to emplace these systems in those types of factory settings and then have to have one or several people have as a full-time job dealing with the robot, overseeing the robot, recovering the robot from errors and mistakes. We don't want that. What we want are those people to be able to continue to do productive jobs in the same setting while the robots take on some other aspect of what would normally be being done, so that they become force multipliers, if you will, to what's ultimately being done. But in order to do that, one, they have to become more capable, whatever that means in the current environment. Smarter, more autonomous, able to recover from their own mistakes and errors and those sorts of things. But they also need to be, to a certain degree, social.
That's interesting.
They have to be, because if I'm a person and I'm working in a factory setting every day and I come to work every day and I punch in or whatever I need to do to start my day, I go on about the business of my responsibilities for the day, and the robots around me are tools, but ideally in the future they're also work partners. Now, I'm not saying that I need to have a conversation with the robots about how was their day overnight in the factory,
Yeah.
right? Or the weather outside or anything like that. But when it comes to doing the job, perhaps if I'm working with a robot to do a particular job, there might be certain cues that I want to communicate to the robot about. Maybe we're carrying a common part, and maybe we're going to carry it across the floor to another location. And I just want to gesture that, okay, we're going off in this direction. I can speak it. I can put the part down and type it into a keyboard, or various different ways. I might even be able to use a technology we call haptics, right? Where maybe I just nudge the part in a certain way and the robot can sense that and therefore take that as a communication that we're about to move in this direction. But in any case, they have to be able to more or less seamlessly interact with and understand their human partners so that they are effective partners. And that's what I mean by some level of the social dimension, to the point where we don't have to stop, sit down, type on a keyboard with monitors in front of us to get them to do the next thing within their workday. So between where we are now today, which is sitting down at a keyboard with monitors, and where we would like to be, none of that. No keyboards, no monitors if you don't really need them. There's some technology development that's still necessary. I like to refer to sort of interaction with robots as we want to move from today, which is head down and hands on, to a future where we are head up and hands off. Right? Our hands are free to do whatever we're doing, but at the same time we can communicate with the robots to get them to do what we need them to do.
I see.
Right?
Yeah.
This will make the people more productive, more able to do what people do best, while the robots are also enhancing overall productivity by doing what they do best.
Yeah.
So it's a sort of a holy grail, if you will, but it's a goal that we're always continually trying to work towards by developing different pieces of technology.
That's right. It's kind of course, it's kind of, if we expect, a robotic to do the thing like our partner, right? We want them, human beings, we're picky, right? Yeah. So we're greedy, and sometimes we're lazy.
Many times, yes.
Right. But anyways, kind of, so to push. So now let's just focus on technology. To push the technologies to that point, and I think I agree with you. You made a very objective assessment. We're not even, on the technology side, we're not even at the point where we can have that robotic partner.
That's right.
Right. So what are some key technological gaps? So for example, you say, when I communicate with that robotic, I don't have to sit down,
Right.
So you have probably like language recognition or something. So what are some kind of more, technical gaps that you feel that exist from today to some kind of, like a semi-ideal working partner?
Right, yes. So it is at least one thing that's a general category on both sides of the equation. One on the robot side and one on the people side. I'll talk about the people side first. So you alluded to it. One is, how do we communicate in a more natural way? Of course, there are some common ways that people in the field have been developing and advancing technologies for. These include speech. And that's not a bad one. For example, technologies like Alexa, like Siri, and all these various conversational interfaces that have behind them the ability at least to pull up knowledge and information from databases, but also the front-end interface that enables them to understand what you're saying and what you're asking. So this technology is here, and we could leverage that for robots in a way that we can enable interaction with robots by just speaking. So that's there, but limitations. If you're using that in a very, very noisy factory environment, you start to get really, really limited in how well you can communicate, right? So that won't be sufficient alone. Then there are things like hand gestures that are a common way in the robotics, human-robot interaction research field that people are looking at. And so maybe you are in a noisy environment. but you still want to communicate, and you have some small library of hand gestures, that you can use that means something to a robot. So as long as they can see you, they can understand what you are trying to communicate and therefore interact. In some cases, seeing you is an issue, right? They have to be line of sight and so forth. Well, it's not entirely a barrier, because you can wear what we call instrumented gloves, if you will, that have certain types of strain gauges and RF communications technology, such that the robot can be around the corner and you can gesture a hand gesture that gets communicated.
Yeah.
So it doesn't have to see you. So that's not a hurdle entirely. But these are some of the ways that people are thinking about. So now beyond that, beyond speech and gesture, another thing that's developing, and this is coming out of the brain-computer interface technology, brain-machine interface technology. You could imagine in the future the ability to at least transmit a small, finite set of discrete thoughts to a robot system or to a machine through such an interface. That might enable yet another mode of interaction. So again, all of these are, to some degree, they push us in the direction of head up, hands off, right? So that's one part of it. We still need to develop along those lines. Brain-computer interfaces, brain-machine interfaces, quite a ways to go.
That's right.
Right? Speech is quite well along, but it will have limitations in certain environments. Gestures, not bad. May or may not be appropriate for your job. If you're carrying something with a robot and both your hands are not free, then you're limited in the hand gestures you can do. Okay. Ideally, your interface with these types of smart or intelligent robots should have all these things, such that you can do what you do normally when you work with a person. So if I'm working with you in a very noisy environment, but I want to communicate, chances are I will succeed, but I probably won't be speaking. And what do? I just switch to another mode that's appropriate for the situation. And so robots in the future will need to have multimodal natural interfaces in order to interact. The other side of the coin is on the robot itself, right?
Yes.
So on the robots themselves, they need to be more capable and more, call it fault tolerant, if you will, or have the ability to recover from minor faults. The main thing there is that not only are they able to potentially carry out a command that a person gives at a very high level, like go to the back of the building and find me the screwdriver, please. Right? Very high level. In order for a robot to be able to do that, there's a whole lot that needs to be on board, or that it can access through a cloud or something like that, that enables it to understand all parts of what that means and thereby can execute it. Right? So there has to be a certain amount of additional development that pushes certain technical frontiers that enable these systems to do more than they can currently do.
I see. Yeah. So, thank you, Ed. Can you talk about these different, very specific, technological issues that we need to address? So, of course, I was just imagining taking iPhone as an example, right? So, before iPhone appeared, right, we had phones. Right, we had phones. It's basically an iPhone itself, right, in terms of like very advanced novel technologies that used in comparison to other phones. I don't necessarily see the big difference in terms of pieces of all those technologies. Right. However, the key thing is really, so I'm kind of evolving from this specific technological pieces that we can use to enable to equip a robot to a way. So my keyword is kind of integration, novel integration, because I'm kind of also alluding towards even back to your young age interest of architecting.
Yes.
Right. So even we have all those pieces of technologies, but from all these different pieces of technology, how do we architect and integrate but turned into a robot.
Yes.
So what's your view? So now we jump out of the technology, but looking at just think of robot as a system. How do we architect them?
Yes.
What are the challenges?
Many. So this is a really good question, and this happens to hit up upon one of the currently active research areas in robotics now. So for many years, we've been really working at what I'll call the subsystem level, trying to work on getting different capabilities to work. We're kind of now at a point now where some of them are working pretty well, not all of them. But ultimately, the demand for being able to integrate them into a more comprehensive product or system is upon us. But we don't have the underlying systematic toolbox that enables us to do that. So this is something that a number of researchers around the world are starting to look at more intently. Certainly there have been architectures around forever as far as robotics is concerned for on board the robot itself and architecture per se. But that's not enough. Yeah, so there's the inter-architecture and what I'll call the intra-architecture.
Yes.
Right? That allows those systems to interact with other systems for whatever reason, right? And I think that we're still developing that as a science. How do you do that? Or at least how do you do that in a systematic way that can be used as a guide or reproduced by future systems? Right now, it's pretty much kind of a one system here, one system there. Oh, we've got a great architecture for this one. But 10 years from then or 5 years from then, can you use that same architecture to develop 3, 4, 5 more types of different robots? Usually not very easily.
That's true.
Right? And so I think the science is still developing. There's one aspect of robotics architecture that has gained some attention over the years, but has not gained a lot of attention as much as the computational architecture, and that is the cognitive architecture. Right? This is the architecture that starts to try to learn from or emulate different aspects of what we understand today about the human brain and how it is architected.
Yes.
And what we can learn from that to architect within a robot, something that can emulate some of the same facilities for reasoning, for thinking through problems, for planning and replanning, and all these different things that will make these robots, again, I mentioned on the robot side of this, they need to become more capable, and this is part of that.
Yeah, so apparently, Ed, I think you mentioned the one thing that those challenges, and also you mentioned kind of the science, the methodology are still evolving.
That's
you
right.
mentioned like kind of our community, we are still lacking of you call a systematic toolbox.
Yes.
Yeah, but one thing, and we're not going into depths, but I just want to raise this.
Yeah.
I feel we can see this kind of integration or architecture. The reason why you want to become architecture because you love drawing, because those drawing, when you do those drawings, actually, I believe there was, of course, you have your internal kind of cognitive procedure to produce those things.
Yes.
But assume that when we're drawing those things, you don't really, in your mind, you don't really have a systematic toolbox.
That's right. That's right.
It's really kind of instinct.
Indeed.
And then also it's kind of. So what I'm trying to say is that kind of to go from now this piece of technology and to some kind of innovative systems, that break the boundaries. Would that be real art, or would that really depend on a systematic toolbox? Maybe both. But
maybe both.
Yeah, we'll leave that.
Yeah.
But you can see that now, given time, you can see that we went from a higher level of needs and go down here. Now I want to kind of come back up a little bit.
Yeah.
Really, assume that we are able to architect and produce these whatever socially responsible, ethically, kind of feasible robots. This is one robot.
Yes.
There's another robot.
Yeah.
Robot, and another. in the end, actually, I was kind of alluded to, and then in the end, they are, as in your word, they are going to become nodes in the whole system.
Indeed.
So now it's kind of, we're jumping out from individual robot and go to a system where robots will be nodes. And then to that place, what do you see as challenges as well as opportunities?
Yeah. Well, one of the clear challenges in that regard is what we are generally thinking about today as cybersecurity, right? How can you protect those nodes from exhibiting anything other than what you designed them to exhibit, right? There's also the sort of a broader system kind of property that is concerning some people, and this is the property of emergence, right? Yeah. If these nodes are connected well enough and exchanging certain types of information that influences their behavior in any sense, does that behavior manifest itself at a higher level as something that emerges from that network that you didn't really anticipate, that you didn't design for? It could be a great quality, but it could be a not so desired quality. But so how do we control, or how do we manage the potential for emergence? That's another challenge. The more we network nodes that have their own intelligence. Now, robot to robot, in that scenario, one of the promising aspects of technology and the way it's going right now is the ability that we expect to be able to have to enable robot C to have the capabilities of robot A by merely transferring software, right? Yeah. Now, they could be of different types. One may have 3 arms, one may have 1 arm, and they may be physically different. But depending on what that software and the capability is like, maybe it manifests itself at a behavior level. For example, there's notions out there about, well, I've got a domestic robot, and it works in my kitchen, and it knows how to cook breakfast, and it has a menu that includes sausages and things like that, but it doesn't know how to create an omelet. Okay, let's allow it to access the cloud, and out there it can find apps for robots. One of those apps is an omelet creating app, and it can download that capability, and the next morning it has the ability to make an omelet, right? So this is not too far-fetched. So I think we are going to end up moving in a direction where, yes, indeed, robots are nodes on a broad network. They're able to share knowledge and information and capability. But again, to your question, there are some yet second and third order things that we need to be thinking about and probably trying to address, like emergence and things like that.
Yes, yeah. That's wonderful. Sounds like, I would, of course, when they become nodes, they're going to be in a network. And one of the powers of network is that through communication, and these nodes can communicate, can learn, can interact with each other. Like, I like that example of how a robot can learn to cook, an omelet.
Indeed.
Right? I think that's very good. So now, and also, we're going to wrap up, but I do want to ask you my last question that I talked with earlier. You can see, you mentioned earlier, you can see in some of the craftsmanship, because, that generation, they're going to retire. Yeah. We're going to lose those know-hows, and we want to work hard. Before they retire, we can hopefully have robots that can learn and inherit those know-hows. Yeah. And also, you presented very exciting opportunities in this area, from the technology level to the systems level, as well as challenges. Yeah. So now my last question is, what kind of future workforce, what kind of people do we need to produce in higher education, such that, we first, how can we equip our future students with the know-hows to produce technologies that can inherit the know-hows?
Yeah. Well, okay, so those are a couple of different questions. I'll try to answer both of them. Remind me about the sort of transference of the know-how. I'll come to that last.
Yeah.
But before getting there, sort of thinking about workforce, definitely what's happening, again, in relation to the type of technology within systems context that we're talking about things that often get scrutinized as things that will replace the job of some people. Now, this has been happening all along as long as automation has been around, right? But more often than not, it creates a new set of jobs for people while taking over some things or facilitating some things. So this is going to continue. Now, in the future, the workforce will need to be able to potentially deal with this type of technology in a pretty seamless way. If there are robots in the very near future working in all work environments, just as an extreme example, and what I mean there is you go into Starbucks in the morning, and not only are there people behind the counter, there's a robot too. Mm-hmm. Maybe the robot is bringing your coffee out to you as you sit at the table. I don't know, right? But imagine, in fact, this is maybe the iRobot movie context, right? They're pervasive, right? Okay, so people in the future, the workforce, will need to be able to know how to interact with this technology, whether it's on a tablet, whether it's on a smartphone, whether it is a robot, right? Mm-hmm. How do I interact with it? How do I understand and become familiar with its capabilities, its apps, if you will? How do I get to a point where I know how to use it? And if I need to, how do I become a power user, right? Think about your cell phone, for example, and you've got N number of apps, and you only use N minus M of them at any given time. But there are the rest of them, but potentially maybe in year 3 of your phone experience, you'll find use for those. Similarly with robots, they'll have certain capabilities that you may or may not need to use, but you need to be able to use them at some point when you want. So what does that mean for the workforce? That means that the workforce that you train in the university, that is the likely workforce that's going to be developing that technology, they need to be thinking and taught how to think about, here's my technology and all its great capabilities, but I need to also know how to build around it a shell that becomes the interface to, for lack of a better word, the common person.
Yes.
Right? What is it that what enables us to take our cell phone, fire up an app with the touch of a finger, and understand the interface enough to use it? We don't need to understand the Python code behind it, the C++ code, whatever. We don't need to know the architecture, but we interact with it through an interface.
Yes.
And almost all of us can do it, even kids. Right?
Yeah.
So it took something for the people who developed all this. It took some effort for them to bring this really high-tech stuff to us and enable us to use it without them in the room.
I think that's so true. It's kind of, when you talk about that, I was thinking, essentially, I think 2 things. First, I feel like we need more Steve Jobs.
Yeah.
Right. Exactly. Kind of. He doesn't necessarily know all the technology, but the interface.
The interface
right?
is terribly important.
Yes, and also I think to produce more Steve Jobs, and I think, again, relate back to you, it's really a combination of in the heart, an artist and an engineer.
Yeah.
Right. These 2 things. Yes, I think this is.
Yeah.
You taught me a lot. So,
I'm glad.
I very much appreciate that. I think given time, I will walk you down. So your talk will be on the 2nd floor.
Okay.
I wish we had more time.
Yeah, I understand. Yes.
It was great to talk to you.
Thank you very much. I enjoyed the conversation.
Yes. Yeah. Good.